All right, we're going to take a look at solving limits algebraically. Like we discussed before, this is the most accurate method if we can solve them using algebra instead of trying to look at a graph or come up with some number approximations. And so we're going to look at 4 ways to do that. You're only actually going to use the first 2 on your worksheet for today on the limits worksheet number 2, but I'm going to go through them all in this video. So first of all, the first way, and actually this is what you should always start with no matter what limit problem you're given, is substitution. What that means is if you have, for example, this one, the limit as x goes to 1 of 3x minus 1, you should always try to plug in the number, the value that you're given for x. Remember, the limit is not always equal to the function value at that point, but if it works, then it will be equal to that because this is a continuous function here. In fact, this one's just a line. So if I try that in this case, if I do, I'm trying to find the limit as x approaches 1 of 3x minus 1. Again, always start by trying to plug it in. Well, if I plug that in, I get 3 times 1, times 1 minus 1, which is just 3 minus 1, or 2. So then we say that the limit as x approaches 1 is 2. Because we substituted it in, it worked, and that is indeed the limit. Always, too, when you're doing these and you're not sure, especially when we get to the ones where you have to do a little bit more algebra, you can graph them and double check. So for example, I could look at this line here and look at when x is 1 and then look at the height of the graph and see that it is indeed 2, just to check your answer. That's an idea. Another thing that we can do, so for this example 2 here, if I try to just substitute this, so if I have the limit as x approaches -1 and I want to know what it is, if I try to plug in -1 here, well, what's going to happen? I'd get -1 squared, which is 1. 1 minus 1 is 0 on top, and then -1 plus 1 is also 0, so I'm getting 0 over 0. Well, when that happens, you can't just assume that it doesn't exist. That's what we call an indeterminate form, which means we're getting 0 over 0 and we're not sure what that actually means. It means we have to do some algebra or something to try to get it to work out. So the second thing, and the one that you're going to do in this problem, is factor and cancel. Okay, so if you notice this right here, we do have the top here is a factorable equation. So we can change this. We can say that this is equal to the limit as x approaches -1 of, if I factor the top here, if you can imagine, you need something that would add to 0 but multiply to -1. Well, that would be x plus 1 and x minus 1 on top. So that's just me factoring the top. The bottom I'm going to leave the same, x plus 1. Then you notice that you have an x plus 1 on the top and an x plus 1 on the bottom. And so then you can go ahead and cancel those two. And then you're just left with the limit as x approaches -1 of x minus 1. Now, once you've done that, once you've factored and canceled, then you can go ahead and try to re-plug in the limit that you're looking for. So if I plug that in here, I'd have -1 minus 1. Well, that just gives me -2. So the limit as x approaches -1 of this function is -2. Again, feel free to go ahead and graph this function and make sure that it looks like when you're looking at -1 for x, that your height of your graph is at -2. So the strategy we used there again was factor and cancel. These two are really all that you will need when you are doing worksheet number 2, limit worksheet number 2. I am going to show you the number 3 and 4. So, example 3 here on the back, you have the limit as x approaches 7 of the square root of x plus 2 minus 3 all over x minus 7. So, this one, we can't factor. We've got a square root going. We're going to do something that is called rationalize. Okay. So we are going to rationalize this one. Another way to say that is, and I'm not sure, I'm sure Miss Damerow taught you this earlier in the year, I guess I didn't look back, but you're gonna multiply by the conjugate. Okay, so I'm gonna go write that for number 3. Number 3, third strategy is to rationalize or multiply by the conjugate. Okay, so what that means is we are going to look to rationalize this top. The way we're going to do that is we're going to multiply the whole thing cleverly by the conjugate. And so we're going to go square root of x plus 2 plus 3, and we're actually going to do that on top and bottom of a fraction. Remember, that'd be like multiplying by 1, right? Multiplying by the same thing over the same thing, that's just like multiplying by 1, which you're totally allowed to do. By the way, I didn't do this, but if you look, if we try to just do straight substitution here, we'll end up with a 0 on the bottom. So that's not going to work. And then actually, if I look here, 7 plus 2 is 9 squared root of 9, so it'd be 0 over 0 again. That's why we need to do something about it. So if I do that, so I'm going to say that this is equal to the limit as x approaches 7. And again, I'm going to multiply top and bottom by 1 in a clever way. We're going to go square root of x plus 2 plus 3 by the conjugate, square root of x plus 2 plus 3. I didn't leave myself very much space there. So I multiply by this on the top and the bottom. Anyway, again, that's just 1, right? Same thing over the same thing, that's just 1. If I multiply then the top, I have to FOIL it out. So I've got this times this. Well, the square root of something times the square root of something is just the something, right? So on top then I will have x plus 2 for the first term, and then the outside will give me plus 3 square root of x plus 2, and the inside will give me minus square root of 3. Minus 3 square root of x plus 2. I'm going to write it out. So plus 3 square root of x plus 2 minus 3 square root of x plus 2. But if you notice, these two cancel. And then our last term, negative 3 times positive 3, is a minus 9 at the end. Okay, the bottom, if I multiply these out on the bottom, I'm actually going to leave that one for now. We're going to see what happens if I leave this as square root of x plus 2 plus 3. I'm going to leave those alone for now. I'm not going to FOIL that out. Okay, so what happened here up on the top? If you notice, these canceled, and then I have an x plus 2 and then a minus 9 over here. Well, I can combine those. So if I go ahead and do that, limit as x approaches 7, well, plus 2 and minus 9, that'd be x minus 7 on top. Well, then what do you notice? I've got that x minus 7 still on the bottom. 2. So this will cancel with that. Then I've got 1 over square root of x plus 2 plus 3. Okay. Now, once I get to this point, I'm going to try plugging this limit in again. So I'm going to try plugging 7 in here. If I do that, I've got 1 over, so 7 plus 2 is 9, so square root of 9 plus 3. Well, the square root of 9 we know is 3, so I've got 1 over 3 plus 3, or 1/6. The limit then, as x approaches 7 of this right here, is 1/6. Again, feel free to graph it and check it. The last thing that I'm going to show you is actually, first of all, check, right? Check substitution. If I plug in 0 here, I'm going to get a 0 on the bottom. And then this one will be 1/4 minus 1/4. So again, 0 over 0. So we're going to try a strategy that is called just finding a common denominator. We're going to put those fractions on top together. Common denominator. That's strategy number 4. That's what I'm going to use here. So if I want to put these two fractions together, in other words, I want to subtract them so that I don't have fractions inside of a fraction, I'm going to find a common denominator. Well, what would be a common denominator here? anytime you have x's like this, you probably are going to assume that your common denominator will be the 2 multiplied together. And in fact, it will here. So our common denominator is going to be 4 times x plus 4. Okay, in other words, just these 2 multiplied together. So I'm going to rewrite this then as the limit as x approaches 0. If I multiply this one by 4 to get a common denominator, this one by x plus 4, I'll end up with 4 over 4x plus 4 minus x plus 4 over 4 times x plus 4. That's just the top. I still have that divided by x on the bottom. Okay. Once I'm at that point then, I am going to actually subtract these. So if I subtract that, x approaches 0, let's see, I'll have 4 minus x plus 4. And then the bottom, again, since I got a common denominator, is just that right there. Okay, still over x for now. Please resist the urge right here to cancel these. This is a minus, okay? This is not being multiplied. You cannot cancel these. You can, however, distribute this negative, and also, so this would be a minus x. This is going to be a minus 4 if I distribute that, get rid of my parentheses. So now I have 4 minus x minus 4. Well, 4 minus 4, those cancel too. So then on the top, I just have a negative x, and then I still have this divided by x on the bottom. Well, you can take care of that. Dividing by x is just multiplying by 1 over x. So if I change that, I've got negative x on top over 4x plus 4, and then I'm going to multiply again by 1 over x. That's the same as dividing by x. Okay? Well, that will give me, first of all, I can cancel, right? I've got cross simplification. I've got an x here and an x there. Those cancel. You'll just end up with negative 1 over 4 times x plus 4. We're getting closer. Now, I'm forgetting my little limit signs here. I'm still trying to find the limit of this, so if I want to do that, I'm just going to squeeze it in. The limit as x approaches 0 of this thing. So now go ahead and try to plug in again and see what happens. Well, if I try to plug that in, plug in 0 again, I get 4 times 0 plus 4. Well, that's just 4 times 4 on the bottom, so you end up with negative, move my paper there, negative 1 on the top, and then on the bottom 4 times 4 is just 16. So the limit as x approaches 0 of this thing up here ended up being negative 1/16. So a little bit of algebra involved, but they're really not too bad if you kind of follow these rules. And again, for your worksheet that is due tomorrow, the only 2 that you really need are these 2, as well as what you already know about graphing.